In this video, we're going to take a look at long multiplication of an application question, which consists of decimal numbers. So a new restaurant plans to buy 27 sets of a particular table, which costs $348.99 each. How much will this cost in the end? I want you to now pause the video and try this multiplication on your own. Remember that the simplest way to perform a long multiplication is to write the long number first, then the smaller number underneath it with their significant digits aligned. So keep in mind here what the significant digits are and where they align up. So go ahead and pause the video and try this application on your own. So if a new restaurant plans to buy 27 sets of this table, and each table will cost $348.99, all we need to do is multiply the number 348.99 times 27. So the larger number will be our multiplicand, and that would be the 348.99. The smaller number of 27 will be our multiplier, but you need to align the significant digits. A 27 would be aligned right here. So what I'm going to do is add two decimal places of 0. 27.00 is the same as 27. So I've aligned everything up appropriately. We put a line under that, and we start our multiplication. So again, I'm going to refer to the larger number as the multiplicand, and I'm going to refer to the smaller number down here as the multiplier. Now with decimal places, what we do is we ignore the decimal places for now, and we throw the decimal place in on the end at the product. So we're going to start off with the last digit in the multiplicand, which is the 9, and we're going to multiply it by the last digit of the multiplier, which is the 0. So 9 times 0 gives us 0. Now we're going to keep working with that 0 in the multiplier, but we're going to move on to the next digit in the multiplicand, which is the 9. 9 times 0 gives us 0. Now again, keep working with the last digit in the multiplier. We're going to go on to the next digit in the multiplicand, which is the 8. And you're going to notice every number in the multiplicand multiplied by that 0 in the multiplier would give us 0. So we're going to write a 0 from 8 times 0. We're going to write another 0 from the 4 times 0. And we're going to write another 0 for the 3 times 0. And we're going to move on to the next digit in the multiplier. Now the next digit in the multiplier is again a 0. However, it's in the 0.1 digit. So we automatically need to write a 0 down below in the 0.01 digit so that we're aligned with the 0.1 digit here. So now we're going to start with the first digit in the multiplicand, which is the 9. 9 times 0 gives us 0. And you're going to go on to the next digit in the multiplicand, but you're going to keep working with that 0 in the multiplier. So the next digit in the multiplicand is the next 9. 9 times 0 gives us 0, and you're going to notice that every number multiplied by 0 gives us 0. So for the next 3 numbers in the multiplicand here, we're going to have to write 3 zeros down below. We're now done with the second 0 in the multiplier, so we're going to move on to the next digit in the multiplier, which is the 7. So we're going to take a look at that 7 in the multiplier, and we're going to multiply by the first digit in the multiplicand. Now before I do this, notice that the 7 in the multiplier is in the ones digit, and so we need to write 2 zeros down below from the 0.01 digit and from the 0.1 digit. And 9 times 7 gives us 63. So we're going to write the 3 from the 63 down below, and we're going to carry the 6 from the 63 forward above the next digit in the multiplicand. So we're going to move on to the next digit of the multiplicand, which is the next 9. 9 times 7 gives us 63, but we need to add the 6 that we carried forward from the previous step. So again, 9 times 7 gives us 63, plus 6 gives us 69. So we're going to write the 9 from the 69 down below, but we're going to carry the 6 from the 69 forward above the next digit in the multiplicand. So the next digit in the multiplicand is now the 8, 8 times 7 gives us 56, but we're going to have to add the 6 that we carried forward from the previous step. So again, 8 times 7 gives us 56, plus 6 gives us 62. So we're going to write the 2 from 62 down below, and we're going to carry the 6 from 62 forward above the next digit in the multiplican. So now we're moving on to the 4 in the multiplican. 7 times 4 gives us 28, but we're going to have to again add the 6 that we carried forward from the previous step. So 28 plus 6 gives us 34. So we're going to write the 4 from 34 down below, but we're going to carry the 3 from the 34 forward above the next digit in the multiplican. So now we're on to the last digit of the multiplican, which is the 3. 7 times 3 gives us 21, but again we're going to have to add the 3 that we carried forward from the previous step. So 21 plus 3 gives us 24, and since we have no more digits in the multiplican, we're just going to write the number 24 down. Now we're done with that 7 in the multiplier, so we're going to go on to the next digit in the multiplier, which is the 2. Now I'm going to erase all the numbers that I carried forward from the previous digit in the multiplier, because we're going to have to probably carry forward more digits, and it starts to get confusing if you don't erase those. So let's go on to the next digit in the multiplier, which is the 2, and we're going to start over again with the first digit of the multiplican, which is the 9. Now again, notice that the 2 is in the tens digit here, so we're going to have to write corresponding zeros up until we get to the tens digit. So this 0 represents the 0.01 digit, this 0 represents the 0.1 digit, this 0 represents the 1 digit, and now we're aligned perfectly for the tens digit. So we can start our multiplication. 9 times 2 gives us 18, so we're going to write the 8 from 18 down below, and we're going to carry the 1 from the 18 up above the next digit in the multiplican. Now move on to the next digit of the multiplican, which is a 9 again. 9 times 2 gives us 18, but we're going to have to add the 1 that we carried forward from the previous step, which gives us 19. We write the 9 down below, and we carry the 1 from 19 forward to the next digit of the multiplican. Now the next digit of the multiplican is the 8. 8 times 2 gives us 16, but plus the 1 gives us 17. So we're going to write the 7 from 17 down below. We're going to carry the 1 forward to the next digit in the multiplican. Now the next digit in the multiplican is the 4. 4 times 2 gives us 8. But we need to add the 1 that we carried forward from the previous step, so that works out to 9. Now we don't need to carry any numbers forward to the next digit in the multiplican, so the next digit of the multiplican is 3. 3 times 2 gives us 6, and there's no more digits in the multiplican, so we're actually done our multiplication. Now our last step is to add up all the aligned numbers. So we're going to start off with adding up all these zeros, and that works out to 0. Now the next step would be to add up all of these zeros, and that would be 0 again. When we add up all of these numbers, we get 3. Moving on to the next set, 9 plus 8 gives us 17, so we're going to write the 7 down below, but we're going to carry the 1 from the 17 forward, and in the next step, 1 plus 0 plus 0 plus 2 plus 9 gives us 12. So we're going to write the 2 from the 12 down below, but we're going to carry the 1 from the 12 forward. Now 1 plus 0 plus 4 plus 7 gives us 12. So we're going to write the 2 from the 12 down below. We're going to carry the 1 from the 12 forward. Now 1 plus 4 plus 9 gives us 14. We're going to write the 4 from the 14 down below, and we're going to carry the 1 from the 14 forward. Finally, the 1 plus the 2 plus the 6 gives us 9, and we're actually finished. This right here is our product. However, we had decimal places in the original question, so we're going to have to put a decimal place somewhere within this product. But where should it go? Well, the general rule is if you have 2 digits from the multiplican past the decimal point, and you have 2 digits from the multiplier past the decimal point, well then you have a total of 4 digits past the decimal point in each number. You're going to start from the end and you're going to move 4 digits to the left, and you're going to place the decimal point right there. Therefore, our final answer is that this new restaurant will spend $9,422.73 when they purchase the 27 tables.